Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of derivatives. So as per the problem, use the graph of a function's derivative to sketch the graph of the original function. So we are given these two graphs that represent the derivative of the functions, and we have to use them to graph the original function. So let's start with the left one, prime of f at x. So let's analyze this given graph. Now this graph is above the x-axis on the left side of the y-axis. So this part here is above the x-axis. So that means prime of f at x is greater than 0 on the left side of the y-axis. That means for x values which are less than 0. Now at x equals 0, the prime of f at x is equal to 0. And to the right side of the y-axis, the prime of f at x graph is below the x-axis. That means prime of f at x is less than 0 for x greater than 0. So we can use this information to write the increasing and decreasing intervals for f at x. So f at x is increasing over the interval negative infinity to 0, which can also be written as x is less than 0. And the function f at x is decreasing over the interval 0 to infinity, or we can write it as x is greater than 0. Now at x equals 0, the derivative is equal to 0, and to the left side of that point the function is increasing, and to the right side the function is decreasing. That means the function f at x has a local maximum at x equals 0, because at x equals 0 the derivative is 0. The derivative means the slope of the tangent to the function. So we can use all of this information to sketch f at x. Now we can see that the prime of f at x has a local maximum at x equals negative half. So at this point. That means the slope of the tangent to the curve has maximum value at x equals negative half. That on the left side of the y-axis. That means the curve should be at its steepest at x equals negative half, and on the other side the function prime of f at x has its lowest point at x equals positive half. So that means on the decreasing part, so the function should have its steepest part or point at x equals positive half at this point. So now we can use this information to sketch f at x. So we can start from the left side. So the function is increasing from left to right towards the local maximum at x equals 0, and we have to make sure that the graph is at its steepest at x equals negative half. So we can show the first part of the graph like this, and then it gradually starts getting horizontal. Now as you can see on the extreme left, the graph of prime of f at x is quite close to the x-axis. That means the graph of f at x should gradually become horizontal as we go towards the left side, because the prime of f at x gets closer to 0. Similarly, on the right side, we can sketch the first part of the function like this, and the graph should be the steepest at x equals half, and then it slowly starts tapering and becomes less steep, and then gradually becomes almost horizontal, because on the right side the prime of f at x approaches almost 0 on the right side. So this can be the graph of f at x. Now we can analyze the second given graph. So this one represents prime of g at x. Now in this graph there is a vertical asymptote. So the asymptote here seems to be at x equals 3. Here. Now to the left side of the vertical asymptote, a part of the graph is above the x-axis and the rest of it is below the x-axis. So we can break up the x-axis into different parts to analyze this graph. So from A to B on the x-axis, prime of g at x is above the x-axis. So from A to B, so prime of g at x is greater than 0. That means from A to B, the function is increasing. So g at x is increasing. Now from B to C, which is x equals 3, the function is decreasing, because prime of g at x is less than 0. So g at x is decreasing. Now from C to D, the function is decreasing, because the graph is below the x-axis. And then from D to E, prime of g at x is greater than 0, because the graph is above the x-axis. So that means g at x is increasing in that interval. So these are some very important observations we need to make before we graph the function from its derivative graph. Now we have to analyze points B and D. Now at point B, the function changes from increasing to decreasing. And at point B, the prime of f at x is equal to 0. So let's analyze point B. So prime of f at x, prime of g at x is equal to 0. And the function changes from increasing to decreasing. That means there is a local max at B. I don't know what the coordinate value is, the x value is at point B. So that's why I've labeled these points A, B, C, D, and E to make the analysis easier to understand. Similarly, at point D, So prime of g at x is equal to 0. That means the tangent is horizontal to g at x at point D, and at point D the function changes from being decreasing on the left side to increasing on its right side. So that means there is a local minimum at D. So now we can use all of this information to graph g at x. So I can use a different color. I can use the yellow color. Yeah. So let's start with the g at x graph on the left side of the vertical asymptote. Now at point B there is a local maximum, so we can show that like this. Now the vertical asymptote will exist for the g at x as well, because this is a graph of a rational function. So therefore the vertical asymptote will exist for g at x as well, because that's the point where the derivative is undefined. So prime of g at x is undefined. Now on the other side, or on the right side of the vertical asymptote, point D is a local minimum. So we can show the graph like this. So, and the vertical asymptote will be the same. So this yellow curve represents g at x. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.